Okay, hi everybody. My name is James Nixon. I am a sound designer at Undead Labs. Before that, I spent a few years working on Crackdown 3, specifically physics and destruction. And so I'd like to give you a quick tour of those systems today. One quick note, we don't have LFE in this room today, so there's going to be a couple things that should sound bigger than they do. All right, so before we get started, I'd like to thank Audiokinetic for setting up the tour. I'd like to thank the guys from Skywalker for giving their excellent talk. Also like to thank Microsoft for hosting and you guys for listening. I also want to take a second to acknowledge the other members of the audio team that contributed to physics and destruction. So Chris Melroth, audio director for Crackdown 3. Josh Bandy, who made a ton of content for the prop system in Campaign. And Dan Crislip from Skew Sound, who did a ton of work making multiplayer cross the finish line at the end there. All right, this is a quick list of what I'd like to cover. So I want to start with an overview of prop physics in the campaign mode, and then a more detailed look at impacts and turbulence. And then we're going to switch gears over to multiplayer and talk about the cloud destruction system and optimizations. Okay, so for a campaign, a brief overview here. We had two main pillars for our physics system. We wanted it to be 100% believable and 100% fun. So we wanted the player to interact with these props for all those interactions to sound exactly as they act. And we wanted those to be fun so that you'd actually seek out all the different props in the game and want to play with them and throw them around. We have a set of core systems that we can categorize into three sets. So handling, collision and destruction, and movement. Within handling, we have grab, pick up, scrape, drop, and throw. If you haven't played Crackdown 3, you pick up objects from a distance using gravity gloves, right? So it's almost kind of like a force pull, right? I can pick up from a distance, it flies to me, and then I can grab it. So the pick up scrape is the sound of the object leaving the ground. The grab is me actually clasping it with my hands. And then at that point, I can then drop the prop on the ground or throw it at someone. Within collision and destruction, we have impact, damage, and destroy. So impact is the sound of objects impacting other objects or static geometry. Damage is the sound of those props taking specific types of damage, so ballistic damage or explosive damage, for example. And then destroy is a system for destroying the props. And in some cases, we would just simply replace the original prop with a damaged version, and in some cases, the prop just completely goes away. And then lastly, we have movement, which includes scrape and turbulence. And we're going to talk a lot about turbulence here in a second. Scrape is very similar, works in the same way. It's just the difference of, am I in the air or am I on the ground? We had a couple of approaches that we took in designing our systems. The first is the idea of two hands clapping. This basically means when we are impacting two objects, how do we have the sound of a wooden box striking a metal dumpster? And the idea is when they collide, we play the sound of a wooden box being impacted on the wooden box and the sound of a metal dumpster being impacted on the metal dumpster. And so put them both together, and it sounds like you have a realistic interaction between these two objects. Now, we had a lot of different props. We had several hundred props in Crackdown, and we really wanted to make each prop as unique as we could. So we actually ended up with something like 220 content sets for props. And almost half of those were bespoke, meaning that they only apply to a single prop, and the rest being shared across multiple props. We took advantage of our level of detail over distance for our impact systems, our damage systems, our turbulence systems, and scrape systems. I'm going to detail a little bit of that in a second here. And then finally, all the sounds in our game go through, I should say almost all the sounds in our game go through Wwise HDR. If you're not familiar with HDR, it's a system for managing dynamic range that attenuates sounds in the mix based on their voice volume. So sounds with louder voice volume will effectively duck sounds with a lower voice volume. And I'm oversimplifying that, but there's some people here you could talk to if you want a better explanation. So the bottom line for us is that that really helped us manage our mix and our voice management in what is a really chaotic game. There's lots of stuff flying around. All right, so let's take a closer look at the impact system. So we have several different layers for impacts. We have the impact and resonance layers, which are standard on all props. And then we also have sweetener layers and LFE layers, which are unique to certain props where appropriate. So each of those layers, the impact is basically the transient of the sound and establishes the material and the intensity with which it is impacting. Resonance is going to be the ring out, or if it's not a particularly resonant prop, it'll be kind of like a whoomp, right? So just sell some of the weight of the prop. But mostly it's reinforcing your material and your mass. Sweeteners, where appropriate, we wanted to add a little bit more detail. So if an impact's happening really up close, we want that to just kind of shine a little bit and have a little bit of extra detail. And then LFE, big things go boom. So each of these layers has a specific set of content based on the intensity of the collision. So impact has fast, medium, and slow. Resonance has fast, medium, slow, and so on. And then each one of those subsets, each of those layer intensity subsets, is given a unique attenuation to scale over distance, and that is per prop. Right? So every prop, every layer, every intensity has its own unique attenuation. So I'm going to play a couple of videos just to give you an idea of these different layers. This first one is just the impact layer by itself. Let me turn that up a bit. Let's try that one more time with a little volume. All right. Thank you. Cool. All right. So next, the resonance layer. Let's see if I can manage this. Okay, and then this particular prop, this is an air conditioner, so we can assume inside are all kinds of little metal fans and little tingy pieces. So we're going to have those rattle around for us a bit on the sweetener layer. Cool. I had a slide for the LFE, but since that's not going to make any sound, I thought I'd skip it. But you can imagine it goes boom. And then here are all of the layers playing together. All right, so here's an example of our attenuation over distance. So I'm going to have, our agent's going to throw our air conditioner from a distance here against that wall, and then pick it up again and throw it at a close distance to give you an idea of how those different layers are scaling through their attenuations. Thank you. All right, so one of the other core systems that we wanted to highlight is the turbulence system. And in short, turbulence is the sound of an object moving through the air. Crackdown has a lot of objects moving through the air. So an object can be picked up from a distance with your gravity gloves. You can then throw it or drop it. The object can be thrown at the player by some of the enemies. And then it's also acted on by impulses like explosions and special weapons. The rules are pretty straightforward. So if an object is in motion and not colliding, we're playing an object turbulence loop. If it stops moving, then we stop that turbulence loop. If an object is in motion in air and then makes contact with the ground, we stop playing object turbulence and then transition into object scrape. So like impacts, turbulence uses multiple layers with turbulence and turbulence resonance being standard on almost all the props. And then we have sweetener and LFE reserved for special props that warrant it. Turbulence, the turbulence layer itself is a sound seed wind patch, a unique one for each one of our props. Turbulence resonance is a loop that's derived from the impact resonance that you just heard before, and that just loops continuously, and that reinforces the size and the material of the object. Really, that kind of sells the identity of the prop. And then turbulence sweetener, in some cases, if we have things that want to rattle around while it's being thrown, then we add a turbulence sweetener layer. LFE is for large objects. If a large object is being thrown over your head, we want to really feel the weight of that kind of coming across us. Now, each layer is given a unique attenuation to scale over distance, just like the impact system. The speed of the object drives voice volume and makeup gain on the sound object, as well as gustiness and wind speed parameters within the sound seed patch. Doppler is added to enhance the pass-by. And then we also apply a tremolo to most prop turbulences to simulate rotational turbulence. And I'm going to talk about that in a little more detail here in a second. But first, I want to just give you some examples of regular prop turbulence. So this is a large boulder. It would have all four layers. So it would have turbulence, turbulence resonance, sweetener, and an LFE. In this case, the sweetener is kind of just like a crumbly rock layer. And I'm clicking on the wrong screen again. All right. Okay. This guy here is a metal pole. And this guy here is a corrugated metal sheet. All right. So in the last one, we heard some of the rotational turbulence that I mentioned before. And so I'm going to give you a quick demo on what we do here. So rotational turbulence system applies a tremolo effect to each of the layers independently, and it controls the rate of that effect using an angular speed RTPC. Angular speed is the rotational speed of the object measured in radians per second. How many people here know what a radian is? That's actually really good. I had no idea before I started. So if you don't, the short answer is it is the angle that's created when you take the radius of a circle and you apply it to the circumference. All right. Now forget what I said, because the only important thing here is that a radian equals 57.3 degrees, and 6.28 radians equals 360 degrees. So if we have a prop rotating, we want to run through our tremolo effect once every 180 degrees. And so to do that, we use increments of 3.14 radians per second. On the x-axis here, we have LFO frequency, and on the y-axis, we have angular speed measured in radians per second. And each point marks a multiple of 3.14. So the faster we're spinning, the faster we run through our tremolo. Angular speed also controls the LFO depth of the tremolo effect, which allows us to tune it across the different layers. And you can see here we have two main share sets that we used on most of our props. One was applied to the turbulence, sweeteners, and LFE layers, and the other to the turbulence resonance. And you can see turbulence resonance gets a little bit more depth. Just felt a little better with that layer. All right, so now I'm going to give you some before and after versions of some props with prop turbulence. So this is a riot shield that is a metal shield prop, and we are going to just kind of swing it past us with no rotational turbulence. Okay, and then the same prop rotating about 3 times per second. Okay, I'll give you another example. This is our boulder prop again that we saw before, at first with no rotational turbulence. All right, and you can kind of hear the kind of crumblies as it comes a little closer. All right, so now with rotational turbulence rotating about 2 times per second. So that is our turbulence system.